Alright, in this video, I'm going to be going over some practice problems for the Unit 8 test in college algebra. These are some questions that are kind of like items on the test that are maybe a little different from how we worked them in class, or maybe they're a little more challenging. So we're going to start with this one where it says, here's the picture of a polynomial, write an equation for the polynomial. So I know that the zeros of this thing are at -2, 1, and 2. So kind of my first idea would be to say maybe it's x plus 2 times x minus 1 times x minus 2. But then I need to make sure that it goes through the point 0, 1. So when I plug in x equals 0, I need to get back y equals 1. Okay, so this is kind of my first hypothesis. So what I'm going to do is I'm going to plug in 0 and see what comes back. Y will equal 0 plus 2 is 2, times 0 minus 1 is -1, times 0 minus 2 is -2. Okay, this means that I'm getting positive 4 back. Okay, this is not what I was hoping for. I was hoping to get y equals 1. So you think to yourself, what could I do to this equation to make sure that when I plug in 0, I get 1? If I'm getting 4 and I want to get 1, I'm going to divide by 4. So I'm going to kind of go back in and clear all this stuff out. And I'll say p of x is equal to this thing multiplied by 1/4. So that we can fit that y-intercept. Okay, that's the type of thing that you might have to do on a test. You're identifying the zeros, so you know what the factors are supposed to be, but there could be a number in front. It's like, how do I choose which number in front to use? Well, it's going to be whichever one fits the y-intercept. Okay, a second one. They're going to give me a third-degree polynomial that is not factorable. Right? Remember that in order for this thing to be factorable, we need to have if the ratio is 1 to 7, this would need to be -14 to whatever -14 times 7 is. So it does not have that parallelism, so it's not factorable. So what you got to do is you got to use the information they're telling you x minus 3 is a factor, so you're going to use synthetic division. If x minus 3 is a factor, then when I plug in 3, I'll get 0. Okay, so I'll run this through and I'll see what happens. Drop that down, multiply, add. Multiply, add. Okay, 30 minus 14 is 16. 16 times 3 is 48. Okay, that's 0. That means that this polynomial is x minus 3 times x squared plus 10x plus 16. Okay. And then you look at x squared plus 10x plus 16, and you can see that this is factorable. So I can say this is x minus 3 times x plus 8 and x plus 2. Okay, so x plus 8 and x plus 2 are the other factors. In a multiple choice setting, it might just say x minus 3 is a factor of this thing, factor the polynomial completely. Something like that. This one's very similar. Okay, it's giving me 1, 0, and it's asking me to find the other zeros. Right, so hopefully when I run -1 through synthetic division, I'm going to get something that's factorable. So let's just have a look. I'm running it through synthetic division. Okay, and I've got myself a quotient. Okay, so I know that what I've got left is, okay, -20, -4x, positive 5x squared, and positive 1x to the third. And if you look at this, this is factorable. 1 to 5 is the same as negative 4 to negative 20. So I start factoring. Think what's common to the first two. X squared is common to the first two. Okay, I go over here and I keep factoring. Then I have x plus 5, x plus 2, and x minus 2. So that means that the other zeros are going to be, well, wherever this thing equals 0. So that'll be negative 5, x equals negative 2, and x equals positive 2. Okay, would be the other zeros. Okay, the next one is just more factoring practice. Okay, this one on the left is the one that's kind of like that new factoring object that we're not as used to, but you're going to factor it in x squared. So it's going to be x squared and some number and x squared and some other number. So you think, what are two numbers that multiply to negative 40 and add to positive 3? Well, that would be positive 8 and negative 5. Okay. And this isn't, x squared minus 5 is not something that I can factor any farther, so I'm going to be done. If that was x squared minus 4, x squared minus 1, or x squared minus 25, it was a difference of 2 squares, then I could go a little farther and get more factors. All right, the one in the middle. This has got a greatest common factor. I see at least 2 powers of x in every term, so I'm going to factor out an x squared. Then I also see that all of these factors are divisible by 5, so I'll factor out a 5. Personally, I'm also going to factor out a negative because I don't like the leading coefficient to be negative when I'm factoring. So I'm factoring out a negative 5x squared, and I think, what do I multiply a negative 5x squared by to get negative 5x to the 4? And that would be x to the 2. This would be minus 4x and plus 4. Okay, then the thing in parentheses, x squared minus 4x plus 4, that's factorable. And that's going to be x minus 2 times x minus 2. And, that might be a safe place to stop if you know what that's the same as. But, if you need to keep going, that's negative 5x squared times x minus 2 squared. Okay, next we've got this one, 3x to the third minus 3x squared minus 12x plus 12. Okay, if you see 4 terms, the only way we're going to be able to factor that is by group and factor. That's a fact for this course. So what I'm going to do is I'm going to say what's common to all 4 terms. I think I'm seeing 3 at least in all 4 of these. So I'm going to factor out a 3. So I'm left with an x to the third minus x to the 2 minus 4x plus 4. And then I can say, okay, well, I'm going to factor out an x squared. I'm left with x minus 1. And a negative 4, and I'm left with x minus 1. So I've got 3. I'm going to factor out this x minus 1. I'm left with an x squared minus 4. X squared minus 4 is factorable. That's the difference of 2 squares. And that's as far as I can go. Okay, this one is definitely modeled after one that's on the test because I realized that the group and factor problems that I'd given you throughout the unit had all been like that previous one where it ended up having a difference of 2 squares and it worked out really nicely with 3 good factors. Okay, that's not what's going to happen here. Okay, this should say x to the third, first of all. That should be x to the third. All right, so it's x to the third plus 6x squared plus 2x plus 12. Okay, so I just start what's common to the first two. X squared times x plus 6 plus 2 times x plus 6. Then I see an x plus 6 in common to both of these things I've added together. Also factor the x plus 6 times x squared plus 2. Okay, we're interested in where this stuff equals 0, because that's the zeros. So, and x squared plus 2 is not something I can factor any farther. So I'm going to say if these two things multiply together to equal 0, then either x plus 6 is equal to 0, or maybe x squared plus 2 is equal to 0. So this is x equals negative 6. This is x squared equals negative 2, which sounds unlikely to me. That's going to require me to take the square root of negative 2, which at this point we're just going to say is not a real number. So the only 0 of this thing is x equals negative 6. So just because it has 4 terms and it looks like something you can group and factor, does not mean that it's always going to work out real perfect with a difference of 2 squares. Last one I've got for y'all is just a nonlinear system, kind of like we've been doing before. And I'm trying to remember what the deal with this one was, but let's just look at it. Okay, so if I have y in both equations, I might as well substitute on y. So I'll say negative 2x plus 1 is equal to x to the third, x squared, 8x, and 1. Okay, I'm going to add 2x to both sides and subtract 1. So I get x to the third plus x squared plus 10x equals 0. Okay, I'm going to start factoring this. And then I'm going to solve. Okay, well, either x is equal to 0, or maybe x squared plus x plus 10 equals 0. Okay, x squared plus x plus 10, that isn't factorable. So in the absence of my thing being factorable, I need to use the quadratic formula. This is x equals negative b plus or minus the square root of b squared minus 4 times a times c is going to be subtract 40 all over 2a. Well, that's not going to be contributing me a solution because I'm taking the square root of negative 39, and that's not a real number. So for x equals 0, I can use y equals 2x plus 1, or negative 2x plus 1. Okay, so that's negative 2 times 0 plus 1, which is going to equal 1. So if I have x equals 0 and y equals 1, then the only solution point is going to be 0, 1. And that's all I've got for you. The rest of the problems on the test are very routine, very much like the problems from the quizzes, from the note packet, from the homework sets. Okay, so that's going to be your best review materials.